twice this one? I suppose is the straight question. Josh has given us the answer, 6 over 5. No, it could not be, because it doesn't work like that, does it?
No, I thought alpha was...
I wish it did.
Maybe. But we do know something about sine alpha. We can use the half the angle if you want to think about it. You can do 2 sine alpha. Cosine alpha is the same as sine double the angle. We just did that example a second ago. So I can use these ratios that I already have to find what the sine of double the angle would be. So that's sine twice 3/5 times 4/5, which is, I think, negative 24 over 25 to give. Sine double alpha. So we never at any stage actually know. We could do arc sine and get the actual angle, but this would be a non-calculator question. So at the moment we just have the ratio. We would know what quadrant, I have a good idea what quadrant that might be in. Double the angle. Yeah, so the original angle is in a quadrant where sine is positive and cosine is negative, isn't it? Am I happy to say that the angle is probably sitting in there, the original? Yeah. And if I double it then, I know that the sine is negative, so more than likely it's going to be here. I'd have to figure out, is the cosine also negative, which we're going to look at now. B, cosine twice the angle. Well, I need one of my other ratios now, so this is where you'd go to your formula booklet or just what you've taken down a second ago. And you'd think, all right, which ratio am I going to use to form it? I can use any one of the 3. Let's pick this one. We could pick either because they'll all work because we have sine and cosine. If you just had cosine, this is obviously the one you'd use. Oh, alpha, sorry, alpha. So twice cosine squared alpha, so that's minus 4/5 squared minus 1. That squared?
32 over 5.
Okay, yeah, 32 over 25 maybe?
Oh, 25.
32 over 25. Take away that 1 is going to leave me with?
7 over 25.
7 over 25. Okay, so a positive. So we're pretty confident with the double. And that would make sense anyway. I don't think logically you could double it and end up here. But, all right, so let's make it sense. The tan of the angle, when it's doubled, we only have 1 that helps us with tan double the angle, and that is the, I've lost it. Here. A little bit more complicated. Tan doubling the angle is going to be twice the tan of the angle, all over 1 minus tan squared the angle. Now, problem, alpha. Problem is, first problem, we don't have what tan of the angle is. A couple of ways I could do it. I could change it to sine over cos. Is that what you were going to say?
No, I was going to ask, can you do tan to alpha equals sine to alpha over cosine to alpha? What?
Yes, so yeah, that's what you're going to say. Yeah,
Oh,
yeah. So do you have to use this if you can go, is tan 2 alpha equal to sine 2 alpha over cosine 2 alpha? No? Yeah, it would be. Yeah, it should be. Well, let's do it both ways and see if we get the same answer. How would I get the tan of alpha if I just started off with this? How would I get the tan? Well, we already know the opposite side is 3 and the hypotenuse is 4, yeah? Not the hypotenuse, the adjacent side is 4.
Isn't that just negative 3 over 4?
Wait, what do you mean
Well, it's just 3/4, isn't it?
Negative.
Now, what quadrant is it in?
Sure, negative.
It has to be negative, yeah? Because it's in the...
How did you do that?
we knew it was in the second quadrant, so tan is always negative in the second quadrant. But also we know that tan is sine over cosine. If you want to just divide 3/5 by 4/5, you get negative 3/4. Or you can think about a right angle triangle with opposite side 3 and adjacent side 4. You could draw it opposite side. If this is alpha over here, 3, 4, and this has to be 5. And you just draw a right angle triangle that suits this. Okay, either way, we have tan alpha to be minus 3/4. Let's do it this way first. I think this way would be the quicker way. Sine is double the angle is minus 24 over 25, and cosine is 7 over 25. So we have a negative 24 over 7. The 25s would cancel. Hopefully we get the same answer here, otherwise we're in a bit of trouble. Twice tan alpha, all over 1 minus tan alpha squared. So I'm using the tan alpha from, that's 3/4, this one. So twice this is minus 6 over 4.
What? Oh, yeah.
9
I thought you did the whole thing is
So that's 1 plus 9 over 25. Well, let's write it down. 1 plus 9 over 25. Oh, minus, yes.
Wait, isn't it a 4 on the bottom or a 5?
That's a 4. Sorry, yeah, that's 16, yeah. I was just looking at 5. Okay, so where are we at? 7. What's this give? 7 over 16.
Negative 6
Negative
over
6 over 4 divided by 7 over 16.
What's that?
which is negative 24.
Now 6 over 4 divided by, so that's multiplied by 16 over 7.
You cancel.
The 4 will cancel here, or go in, so that's minus 24 over 7. Wasn't looking like it for a second, but it did pull through for a second. So it's definitely easier to do this way if you have both sine and cosine to work using this one. Okay, hopefully that makes a bit of sense. What happens in the second example here?
Wait, why did they make it more complicated?
Why did they make it more complicated?
Yeah, with that.
If you only have tan, this one might be easier. If you had sine and cosine already, this is just pretty simple to do. Okay, the next question then, you're only given sine alpha for this. So our restriction is here, and we know that alpha is, we have to think about this with any answer, that alpha is in that second quadrant. So if I were to draw it, it's once again sitting over here somewhere, I think. Find the exact value of sine 2 alpha. So sine 2 alpha, the only formula identity I can use, I think, is this one. That was the first one we had. Okay, but I don't know what cosine alpha is. How do I get cosine alpha if I don't know it and I have sine alpha?
Pi minus.
You can think about it. We don't have the angle either, do we? So we're working with, these are not the normal ratios that we're dealing with. So how do I get the ratio for cosine if I only have the ratio for sine?
We should go back to the triangle, dude. Pythagoras defined that.
Yes, very good. If you have an alpha here and you know the opposite side is 5 in the ratio 13, the other side would be in the ratio, what's this side going to be?
169 minus 25 is.
It's one of our Pythagorean,
11.
thank you, 12. One of our Pythagorean triplets.
How'd you guys get 11?
144 and 25 gives 169. Okay, so we have this adjacent side now. So the adjacent side would be in the ratio 12 to 13. Or the cosine would be in the ratio 2. So now we have it. So if you don't have both ratios, you can get them pretty easily if you have one. So this is now twice 5 over 13 times 12 over 13, which gives
120 over 169.
okay.
Wait.
Two, twice. Okay.
Josh's head. That's why. Josh's
You know, man.
Now, I'm not happy with that answer. Why am I not happy with that answer? Because it's annoying? Yes, maybe.
huge.
Also, I'm not happy with...
Massive.
Anybody else going to figure out what's wrong with this answer?
It's not.
Why am I not happy? And it's not because it's an annoying number.
You gotta divide by 2. I don't know.
Someone will figure it out.
Why are
Give
we
me 10
not?
seconds. Was the only thing we've ignored so far in the question.
Do the pi
Oh,
over two,
the
alpha pi.
Pi, yeah, the range.
Yeah, we didn't look at the range. So
It's in the range.
yeah, okay.
it's not within the range.
Oh no, it is.
Okay. So if the angle started off here, which is what this said, if I double it, where's it going to be?
Double what?
Pi and
It's definitely going to be on this side, isn't it?
yeah.
Which means the sine of an angle on that side is negative.
Sorry, can you repeat that one more time?
Yep. If the original angle is here, and I double that angle,
How do we know that the angle? Or you just, is this just a scenario?
sine alpha and the angle's been doubled to sine 2 alpha.
Yeah.
So yeah, it's going to have to be in, well, this quadrant, isn't it? And sine is negative in that quadrant.
Isn't it negative in both quadrants?
Hmm?
Isn't it negative? In
Oh,
both
it could be in this quadrant, actually. It's negative in both quadrants, yeah, I know.
Why'd you change it to a negative?
Because sine is negative in here and here.
That's the formula doesn't show negative.
Well,
How do you just guess where 5 over 13 is?
it's not the range.
How did I guess with 5 over?
How does it become negative, right?
Yeah, I'm trying.
What?
Now,
It's above 0.
now, my mistake was mistake was made probably earlier on in the question, but I noticed it at the end. Because alpha is in this quadrant, this should have been negative, shouldn't it?
But
That
why-
this
why is it-
should have been, and I would have got the same answer.
Why isn't alpha in the top right quadrant?
Because alpha is greater than 90 and less than 180.
Why is that
I
close?
understand it.
So I've made the mistake here, but I noticed it at the end
That's why it's
that
negative.
that answer was impossible.
What?
Okay, yeah.
Oh,
Why?
because it's plus minus 12. Is that why?
No, it's like in between 90 degrees and 180 degrees. That's where the angle.
This says the angle, the original angle, lies between 90 degrees and 180 degrees, which means it has to be in this quadrant. In that quadrant, sine is positive and cosine is negative.
Yeah.
So I caught it here because I noticed that double the angle has to be in, the sine has to be negative of double the angle, because if it's sat here, double it's going to sit there somewhere. Okay. Tan 2 alpha then. Tan 2 alpha is more the same, sine divided by the cosine. Once we have the sine of double divided by cosine double, but this time we don't have cosine of the double. So maybe if you don't want to do your, I would probably just go to this, and I know the tan is what?
5 over 12.
5 over 12, and then that's where I'd use that tan formula. Tan alpha is 5 over 12. Is it positive or negative though?
It is negative.
It would be negative in this quadrant, yes. So negative.
It's in the bottom right quadrant. That's where alpha is. 2 alpha.
Okay, and then I'd finish off with doing this 1 minus 5 over 12 squared. And then I'd try and, you okay? That's minus 10 over 12 and 25, 144, 1 minus 25, and you'd simplify this down as much as you can. I think you're going to get a negative number.
119 over 144.
So 119 over 144. If you want to times 120, yeah. Over 144. Is it that?
Yeah, that is. What? What did you? How'd you?
Which bit?
The answer's right. How'd you do that? Where do you go?
Times by 12 over 12.
Yeah.
Oh.
Okay. Yeah, just find a common denominator. So it cancel.
No, it took me a second. So this is where the original. Look, I show you. Excuse me.
Okay.
Look.
Yeah.
See in this one. Yes.
Dude, Alex just wants to be on YouTube.
Alright, fine. This is qualitative. I just wanted to make an appearance. You didn't even work it. I did. I was thinking. Look, no, so signs where the X is, the sign is positive.
He's definitely
Yes. I said it earlier.
Okay, he's gonna figure it out.
Understand it? Yes.
Okay, so sometimes.
We're listening.
I know some of you listen. Gotta get 2 people. Okay, sometimes you gotta work backwards. This time they give you the double angle and you gotta work back to the single angle. So if I have cosine 2 alpha, this is a new question, is equal to 3/4, how do I work back then and find what cosine alpha is from this? So this is where you go back to your
Wait, are we doing it?
formula. I'll do it. You'll be doing them in a second. So which one am I going to use of the 3 for cosine double angle? Which one do you think is the most relevant? You should have them in your notes. We're going to go for, we're trying to find cos. Yes, 2 cos squared minus 1 to find what cosine alpha would be. So if I know that's 3/4.
Why would you choose that? Why did you choose that one?
Because the other one has cos and sine in it, and another one has sine in it, and I'm doing part A, which is looking for cosine. So I'm trying to limit the number of variables. There's only one. So add 1 over here. 7 over 4, divide by 2. 7 over 8 is equal to cosine squared alpha. So cos alpha is the square root of 7 over 8. Now I'll look at plus minus, but then I think about, does the question restrict it in any way?
No. It's acute. Yes, it does. Acute. It's a small angle, which means
So
positive. Oh, yeah.
So it's just positive, only the positive. It says in the question that it's an acute angle, so less than 90 degrees, so cosine can only be positive. How do I then go about finding sine of the angle?
The other formula.
Bunch of ways using the other formula. Yeah. So you could do that. You could finish that, I hope.
Wait, can you explain the acute part?
Yeah, so the angle is acute. So if the angle is acute, that means it says alpha is acute, so alpha sits here. It's in this quadrant.
Oh,
so-
it's not,
and-
it's smaller than 9.
So I can't say minus. Yeah. Okay.
Wait, what?
I can't say it's a minus cosine. Cosine is positive in that quadrant. And sine is positive. Okay. You could work and find sine. Okay. The next one then, some manipulation, just simplifying like you did for homework, but with more formulas this time to work with. If I have 3 sine theta cosine theta, how can I simplify this a little bit? It's meant to be an arrow. How would I simplify that? 1.5, yeah, so let's use fractions. 3 over 2, yes. 3 over 2 times 2 sine theta cosine theta is an equivalent to that, isn't it? Why did I pick this? Because this is one of the ones in my list of trig identities, and I can shorten it down to just using sine then. This is sine 2 theta, isn't it?
Yeah.
3 over 2 sine 2 theta is a slight tidy up.
Oh, that's it.
Yeah, I'm only simplifying. So that's the kind of the idea you're getting here.
Where?
This is the your sine 2 theta is equal to 2 sine theta cosine theta. This is the first one we had.
Where did we get that?
The first one we had
Josh, the one that we
just today.
Oh, this one
You
today.
have to memorize all of them.
No, they're in your formula booklet. I'm using the formula booklet. That's
Okay,
why.
the ones today are for the formula booklet. The ones from yesterday are not.
Okay, let's do one further example before we set you on your way. Let's look at these.
Is this homework?
This is part of your homework. So this is the hardest question on your homework. So let's look at it. Which one would you like to do?
18H.
Of course. If you want. Okay. Cosine x.
I have a feeling that's not even the hardest one.
I don't know. I haven't done it yet, so we're going to find out. Sin x minus 1 equals 0. Okay, I want to solve this in the domain 0 up to 2 pi. Yeah, it looks like a quadratic, but we got to form a quadratic out of it. Did I forget something? No. Okay, any thoughts? I haven't done this before, so what would you do?
Okay, wait.
Do you want to give it a go first? No. You want, all right, 2 sine x cosine x, a good start. So you,
Wait, what? Oh, yeah. Those
Okay.
genius. Those good genius.
Rules.
Those good genius, dude.
okay.
Oh, that's a lot.
Oh, the
It's a lot better.
negative 2 sine x minus 1. Is it minus 1?
I'd love to have it all in sine, all in cosine, or all in tan. I'd love to have it all in one of those.
It's a quadratic, not really, kind of.
No.
What do you mean it's a quadratic, not really?
Like, like you can put it into the two bracket thingies.
That means it's a quadratic, genius.
Yeah, I just said it was.
Can
No,
you?
you said
Yeah.
no,
you can't.
You should be able to. Yeah, you can.
All right. So
you
2
could.
sine x cosine x.
Negative cosine. Negative cosine.
Negative cosine x?
Are you serious
Yeah.
right now? No, you already
I wouldn't put the negative
No,
there.
negative 2 sine x and negative cosine x.
Josh, there are 4 terms.
Well, there's 4 terms when you do this multiplication. Maybe he's right. Maybe he's right. So this times this does give the first term. This times this does give that.
Oh, Josh.
Oh, this times this does give that. And this times this. So what sign must this be? Plus, he's a genius. He's a genius. And then you can finish. So 2 sine x plus 1 equals 0. Sine x then is equal to negative 1/2. And cosine x is equal to 1. How do I finish this off then?
X is 9 and X is negative 5/6.
Cosine x is 1 twice, I think, isn't it? X here is 0 and 2 pi, no?
What?
Yes.
In this.
Oh, yeah.
Okay, and this one, negative 1/2, negative 1/2, here and here.
7 pi over 6 and 11 pi over 6.
Yes, so one more. So my reference angle is pi over 6.
Isn't it 0 pi and 2